Good morning, all of you. In today's session, actually, this will be either the last or the penultimate session of acid-basis salt. Today, actually, we are going to discuss one concept called deliquescence, efflorescence, and hygroscopy. So, we are going to discuss that today. So, first of all, first thing that you have to understand is that many salts intrinsically within their crystal itself they have water molecules, like the water molecules are inbuilt into the crystal of the salt, and that is known as water of crystallization because those water molecules are part of the crystal structure. So if you have CuSO4.5H2O, then CuSO4.5H2O is a bluish crystal. Okay, it is a bluish crystal, and if you heat this crystal, you will get CuSO4 plus 5H2O. So what will happen is that after the heating, the blue color will go away. The blue color will go away and you will get a white powder, right? So this is a blue crystal, CuSO4.5H2O. After you heat it, the blue color will go away because the inherent water molecules which are there inherently, those water molecules, they will evaporate due to the heating and you will get a white powder. So you can see that water of crystallization is a very important thing because in case of crystalline salts, it is the reason why the salt has got a color. So the blue color is due to water of crystallization, and when you heat it, the blue color goes away and it becomes a white powder, right? Now the thing is that so the thing is that suppose if you, after heating this crystal, after heating the copper sulfate crystal, if you allow it to condense back, like you have heated the crystal, you allow it to condense back, you just want to see whether it will condense and again give back the crystal or not. Now when this copper sulfate is heated in a test tube, when the condensation happens, the liquid which is obtained, that liquid, it turns cobalt chloride from blue to pale pink, right? So once again, the test tube in which you are heating the copper sulfate crystal, in that test tube, at the upper end of the test tube, if condensation takes place, the liquid which is obtained in the condensation, it will turn cobalt chloride from blue to pale pink. So that clearly shows that that liquid is only water, it doesn't have any copper sulfate crystal at all. So this is a confirmed test that the crystal cannot be reobtained by condensation, right? So water of crystallization is an intrinsic property of the crystal, and if you heat the crystal, then the water will evaporate, and if you condense in the same test tube, you will get water but you will not get back the crystal, right? Okay. Now the thing is that if you take another crystal potassium nitrate, okay, if you take potassium nitrate, so what will happen is that on heating potassium nitrate, you will get a colorless liquid KNO2 and you will get oxygen gas, right? So if you heat potassium nitrate crystals, if you heat them, then actually you will get a pale yellow residue. This is a pale yellow residue So on heating potassium nitrate, you will get a pale yellow residue of KNO2 and you will get oxygen gas, but you will not get any water. So what does this prove? That all substances don't contain water of crystallization. Copper sulfate contains, but potassium nitrate does not contain water of crystallization. Okay, now we will move on to the topic efflorescence. Okay, efflorescence. So we will move on to the topic efflorescence. So in efflorescence, what happens? You have to take a crystal, and if you expose it to air, right? If you expose it to air, then it will lose its water of crystallization. So Na2CO3 dot 10H2O, if you expose it to air, it will lose its water of crystallization. So NO2CO3 dot NH2O has 10 water of crystallization, and if you expose it to air, then out of 10 it will lose 9 and you will get Na2CO3 dot H2O. And ultimately, after the loss of water of crystallization, Na2CO3 dot NH2O will become a powder. It will become a powder. So it was initially a crystal, it will become a powder. So similarly, Na2SO4 dot NH2 exposure to air gives Na2SO4 plus 10H2O. So this will also become a powder, and MgSO4 dot 7H2O on exposure to air gives MgSO4 dot H2O plus 6H2O. So these substances, these three substances display a property called efflorescence. Efflorescence means that on exposure to air, they will lose the water of crystallization. That means they will lose the crystal character and become a powdery substance. Okay, now have a look at these compounds: NaOH, KOH, MgCl2, ZnCl2, CaCl2, FeCl3, ZnNO3 whole twice, and CuNO3 whole twice. Now these substances, they are called deliquescent. They are called deliquescent. So deliquescent means that if you expose them to atmospheric moisture, then they will dissolve in the atmospheric moisture and form a saturated solution. So they will, if you expose them to atmospheric moisture, then they will dissolve in the atmospheric moisture and give a saturated solution. And that property is known as deliquescence. So all these substances are deliquescent substances. Okay, now there are a few substances given here: concentrated H2SO4, P2O5, CaO and silica gel. Now these substances have a property called hygroscopy. What is hygroscopy? Hygroscopy means that on exposure to air, these substances will absorb moisture from the air, right? Just like deliquescence. In deliquescence, the substances will absorb moisture and dissolve. In hygroscopy, they will absorb moisture, but they will not dissolve in it. That is the difference between deliquescence and hygroscopy. So basically, that is how we can separate deliquescence and hygroscopy. So hygroscopy means they will absorb moisture, but they will not dissolve in it, right? Okay, now your homework is that whatever crystals I have written here, you will just have to write one list, the name of the crystal, the literal name of the crystal, and you will have to send it as your homework. So I am just marking those crystals. So these compounds which I have, some of them are crystals, some of them are, okay, so Na2CO3 dot NH2, Na2SO4 dot NH2, NaBSO4 dot 7H2O, NaOH, KOH, MgCl2, ZnCl2, CaCl2, FeCl3, ZnNO3 whole twice and CuNO3 whole twice, P2O5 and CaO. So you will have to write down the names of these compounds and make a list of the names of these compounds, write the compound and its name and send it as your homework, and you can send it by 9 p.m. tomorrow because there is no homework session today. Thanks a lot. Bye all of you.